All right, I am showing that it is noon Central Time, so we have a lot of ground to cover. So I will go ahead and get started. Wanted to welcome everyone to the third event of the Technology and Planning webinar series presented to you by House of Levine. We're going to be discussing how we navigate the future by integrating GIS and digital twins for effective planning. This is, as I mentioned, this is the third event in this series. If you haven't had a chance yet, and I hope Dan will share the link to this later on, but the previous two events of this have been recorded. If you're a planner that feels like you've been a little overwhelmed with, are we using technology, specifically GIS, the best way that we can within our planning department? If you feel a little overwhelmed with that, that's easy to do. This is an invaluable resource for you, and there's some great repeatable and relatable examples to this, and that you'll see in these. So I'd strongly encourage you, go back, see the recordings. Even if you've seen it before, there's maybe some things that you missed. So hope you'll take advantage of this resource. It's really been enjoyable for me to be a small part of this and see some of these real world examples. So as I mentioned, my name is Keith Cook. I'm the industry manager at Esri for planning and community development. So one of the great things that I get to do is I get to work with some outstanding business partners, some innovative business partners like what you're going to see today with House of Levine. I'm joined by Devin Levine, who's a partner and co-founder at House of Levine. Sujan Shrestha, I hope I got the name right. You can yell at me later if I didn't, Sujan. And my former colleague, Rob Stauder, will be joining as well with some really impressive examples. You're going to be a little blown away at some of the stuff they show. I won't lie, but I want you to not focus just on how awesome it is and think, oh, this is something we can't do. It actually is. Some of the examples that Sujan are going to show are not from two huge metropolis areas. They're from Morrisville, North Carolina, and Glen Ellen, Illinois. They're leveraging digital twins, and I think you'll see that this is something that's absolutely attainable for you. So just a little bit of context before I hand it over to Devin. If you're not familiar, digital twins are essentially a virtual representation of the real world, right? So that includes physical objects, their relationships with one another, their behaviors, and so forth. And GIS is really the foundation to create these digital twins. We do this in both the built and the natural environment. And it helps us to, GIS helps us to be able to capture real-time data, integrate it, capture all sorts of data, visualize it, and be able to tie it together so we can make better decisions. And it's really a foundation for smart cities and a modern approach to planning. The one thing I'd love for you to take away from this, though, is we talk about 3D and the importance of it. 3D is no longer a luxury. It just isn't. It's how planners have thought and worked for decades. And the tools are there now. They're attainable to be able to use today to be able to leverage 3D. It is not the burden that it was 10 years ago, both in terms of cost and complexity. It's there, and you're going to see some great examples of that today. Now, once we have the digital twins, once we've built those and leveraged them, we can use GIS to leverage tools like ArcGIS Urban, where we can leverage that digital twin for urban design and planning. So this is where we can come up with multiple development scenarios, evaluate those, analyze them, compare them to others. What would a medium density residential look like as opposed to a mixed use development? How many households and jobs are we going to bring in? What's the impact going to be on utilities and traffic and tax revenue and so forth? That's how we can leverage a digital twin here in something like ArcGIS Urban. But ArcGIS Urban doesn't exist by itself. It's part of a holistic approach to planning and community development. And I will not go through all of these with you, but there are some really important tools here, like if you need to leverage more business intelligence from your permitting system, that's where ArcGIS Insights comes in. Better engage the public, ArcGIS Hub, story maps to be able to tell your story. Some fantastic tools in that regard. But it's not just the software, right? The software is great. We have to have that. But then we also have to have service offerings to help with implementation, whether it's because of lack of expertise or bandwidth issues. There are services that Esri provides, but also our partners like House of Levine. because one of the big differences is, yes, we have some great professional services people. We do not run a planning practice. You will be happy to know there is no chance of me rewriting your comp plan for you. That's where folks like House will come in and do some great work. And so in the end, what we're doing with these digital twins, really, and this is the overriding theme throughout this, is we're really transforming the planning department with GIS, specifically with ArcGIS. So whether it's just the day-to-day operations, the current planning, long-range planning, whether we're trying to drive sustainable development, making sure we're giving everyone a voice through civic inclusion, we're empowering our field crews through code enforcement inspections, or again, getting more squeezing more value out of our permitting system. That's really what this is at the core of it. That's what this is about. So I'll be on at the end to help out with some of the Q&A. I'm looking forward to seeing some of these examples. But with that, Devin, I will pass it over to you.
Great. All right, should be able to see my screen. So thanks for the great introduction, Keith, and the kind words about the firm. And I want to thank everyone for joining us here today, spending your lunch hour with us. If you don't know who we are, House of Levine, we are an urban planning, design, and geospatial services firm. We like to say we're powering the art of planning with science and technology. And we focus on leveraging evidence-based decision-making along with graphically compelling and effective storytelling. We do plan at all scales. We have about 450, almost 500 projects from digital twins, master plans, zoning ordinances, comprehensive plans, all types of studies. So from an entire region all the way down to a specific parcel. We have national and international experience, work just about all over the country, and due largely in part to our work in digital twins. We've had the privilege of working on some of the most exciting projects happening right now in the world. And we like to be innovative and fun, and it's really that mentality has really helped push us into this realm. We are recognized leaders in leveraging GIS for planning and digital twins. We are part of the Esri Partner Network. We're a gold partner. It's about 3,000 partners in the program. I think it's about 90 gold partners. So we're in a pretty esteemed group of companies that use Esri software and work with Esri to help communities achieve their goals and visions. We have an ArcGIS urban specialty. Keith touched on urban. That's just sort of our way of proving to Esri we know the software inside and out. So they've designated us as an urban specialty holder. We also have a specialty called System Ready, which is the big one. That is to make sure that the partners are current on all the latest technology within the Esri platform. So we've received Special Achievement in GIS Awards, or SAG Awards, for our work from Esri in 2018, 2020, 2021. And just this past summer, we received our 4th award, and something we're proud of. This year in Palm Springs in March at the Esri Partner Conference, we received the Innovation Award, so given to the Esri partner that was doing the most innovative work in GIS. So what is a digital twin? All this slide comes from the Digital Twin Consortium. Digital twin is a virtual representation of real-world entities and processes synchronized at specific frequency and fidelity. So digital twins are systems that transform business and accelerating with a holistic understanding, optimal decision-making, and effective action. They use real-time and historic data to represent the past and present and predicted futures. And they're motivated by outcomes tailored to use cases, and they're powered by integration built on data and guided by domain knowledge, and then implemented through IT and OT systems. So what does that mean to Esri? Esri is a member of the Digital Twin Consortium. They sort of more narrowly define it as a virtual representation of the real world, including physical objects, processes, relationships, and behaviors. And GIS creates digital twins of the natural and built environments and uniquely integrates the two. Geospatial technology connects the different types of data and systems to create that single view, and it's accessed throughout the complete life cycle of a project. And then they go on to say that GIS can enhance data capture and integration, enable better real-time visualization, provide advanced analysis and automation of future predictions. So I think put a little more topically, how are our digital twins and our work in digital twins being used? This is whether it's by us or by our clients to visualize proposed developments in a real world context, to aid in assessing their potential impacts, to virtually simulate and test different planning recommendations before they're implemented. We've integrated real-time data to inform data-driven decision making. We've created immersive and virtual experiences as a marketing tool, allowing potential buyers to tour master plans and developments before they're built to either invest or purchase real estate. And we've even done virtual exploration and interactive experiences for tourism. And so we'll touch on all these in the next hour. What's in our toolbox is a question we get asked a lot. How do we do and build the work that we do? You can see the Esri software on the left plays a big role. ArcGIS Pro, CityEngine, Urban, online and enterprise. The difference being enterprise is behind a firewall on premise. And then the ArcGIS Maps SDK. It's a more recent product by Esri. It really, what it does is it brings ArcGIS into game engines. And then on the right, these are some of the other tools we use. We use SketchUp, Unreal Engine, Twinmotion, Autodesk Revit, Invicar's Twinit.io. It's a digital twin platform. And most recently, we started to jump into NVIDIA's Omniverse. And so when we build these, we're in and out of a bunch of different tools. So I'm going to start this off with a poll question. Before we jump into the case studies, I'm going to have Dan put a poll question on the screen and we'll gauge the audience. Dan? I can't see the poll question. Dan, is it up? Oh, there it is. Sorry. Does your community need a digital twin product to support decision-making and planning efforts? So just go ahead and submit and let's see, checking the results. Coming in, let's see, we got 32%. We're interested but haven't looked into it. So about a third. The other third is looking into it. So 2/3 sort of we needed it yesterday, 15%. So, all right. So how we got started, this is something that we get asked to quite a bit. So I'll run through this quick. It started with a digital twin of our office. We took our floor plan. One of the things we do on occasion is let off some steam playing video games. If we're celebrating like a big project win or adoption of a plan, we'll bring in lunch and we'll play a game called Counter-Strike. And one of the things we thought of, could we get our office into the game? And so we took that floor plan and started to explore what it would be like. Went around our office building, captured some photos. We started to sort of dimension out and sketch out our furniture, things that we'd have to model. And then we started to look at downtown Chicago. We're sitting at the intersection of Randolph and Wells. And so we built a 3D model of downtown Chicago. And then we used some Esri tools, some viewshed analysis to help us thin out that polygon. We didn't want to create a 3D model of every building in the loop. And so we looked at what you would see from our office using a viewshed analysis. That helped us thin the polygons considerably from, I think, about 4,000 facades to about 100 118, I think was the total number. And then we looked at things like the street. What does the street look like in front of our office? And then we built those textures in Photoshop, sort of just stressing the pavement like we saw. We went around, we took photos, and the result we're thrilled with. This is the sign when you walk into our office, and this is what it looks like inside of that Counter-Strike, that Source game engine. Little trip through our kitchen, John Housefield's office, my office, our conference room, just a view out over the street. So this whole story was published in a blog article by Esri. We posted it on YouTube, and we had some clients ask us if we could start to build out digital twins for their downtowns and their areas. And so it really kicked us off. So here's a Google Street View of our office. I'm sort of sitting in this window right up here. And then this is what we built in the game. And then here is a look down Randolph Street in Street View, and here is inside the game. So that's how we got started. When we talk about digital twins, we have a few core concepts we like to bring our clients through. We use something called procedural modeling. We use CityEngine a lot. What we do is we take rules that take a footprint or center line, and we're able to drive that into 3D shape creation. And then we're able to use these attributes on the right to drive the ultimate design. So we can do things like add a green roof or change the height of a building, color the awnings, the placement of the windows. It's really just a design tool to help us through big study areas. Sorry. There's a concept called LOD when you're talking about 3D. So LOD1, simple extruded masses. LOD2, we segment out those footprints. We split the masses. 2.5, we're adding detail. LOD3, we're texturing geometry, whether it's random, like the buildings in the background of this stack, or the building in the foreground, which is the building across the street from me, where we capture that imagery and then texture map it. And then 4 is detailed geometry, where the glass behaves like glass. We're seeing reflections. The concrete would have a roughness to it. LOD5, if we need to do manual modeling, we'll jump into Rhino, Blender, Revit, whatever it is, and we'll do these hero buildings or buildings that just can't, CityEngine just can't procedurally model. If we're doing a large area, we leverage typologies. So instead of building every single street in a city, we'll identify sort of the typicals or the street typologies of a community, and then we take those typologies and apply them broadly across the city. Another thing we do, and this is something we need to know early on, are we doing sort of a fly-through, or are we going to build an interactive application? If we're doing a fly-through, we'll use either Omniverse or Twinmotion. If we're building an interactive application, we'll use the Unreal Engine to put a character in a map, and we'll walk through all of these. So the first case study is Cypress, California. We're working with them on a housing element, and they were mandated by the state to provide about 4,000 dwelling units throughout the city. And we identified this site as a strip mall, as a site that it could accommodate about 200 dwelling units. So we planned it out with with SketchUp. It could have been CAD though, or Rhino, or whatever drawing tool. And then we brought it into CityEngine, where we started to sort of drive the design. So this is a parking wrap. It's a parking deck nestled into a condo building. We got about 200 units on this site. All that reporting coming out of CityEngine. Keith mentioned the dashboards and the spatial intelligence. So as we use these tools to build the our 3D models and our visualizations, we're getting real feedback on certain things. So this, we knew we had about 200 units, and we also kept the same amount of square feet of retail on that site. So this was shared to our client with as a 3D web scene. They're able to in their browser go to the site, look at it, pan around, they can sort of see the site from any angle. They could expand it, query it, get all that metadata out of that CityEngine reports out, so they can see for themselves what the average dwelling unit size is, and construction cost, absorption rate, anything we program into our models, we can come out. And this one we took it and we explored some AR. So we wanted to have look into augmented reality. So this is an app you can download on the App Store if you have an iPhone. And I can take a coffee table and holding my phone, it'll scan that horizontal plane, and I can place the model onto a table. So if you wanted to have think of a conference room, you could pull that out, and that model will sort of sit. And so, and then we can expand it. You can see how that parking deck nestles in. So this is just would work on any surface. You can also use it with image tracking. And so if I click on this image tracking example, as soon as it recognizes the site or the parcel, it puts the building right on it, right where it's positioned to be. And what's great about this is, you can sort of rotate the paper and it rotates the 3D model. So here's an example where we used a digital twin to end an impasse. We're working with a community, Morrisville, North Carolina. It's in the Raleigh-Durham Research Triangle. And part of the outreach that we did an extensive amount of outreach with this community, finding out what they wanted. What we learned was they wanted a town center. It was sort of a suburb that grew up without a focal point, a traditional downtown. And they did have this plan that was done in 2007 that was guiding it, but it was deemed insufficient by the community. So they asked us to, in addition to doing the town-wide plan, to take a real good look at the town center and propose some options to them. And what we learned was that the community was afraid to move forward with a vision because there was a divide among the leadership, whether or not they wanted a one-story building with surface parking or multi-story buildings with parking garages. So this is the area identified as the town center. Everything in blue is public uses. You have the town hall, police station, planning office, health department, and a public library that was just built. But everything in red is the area that they wanted to have this mixed use town center. We did a market study to make sure there was market viability. We also asked our client to give us some precedent imagery. What are the types of examples they want to see? And then from there, we did a simple land use program, and we did 2 alternatives for this. You got to pay attention close here when I switch to alternative 2 to see the change. The graphic doesn't change because the only difference between alternative 1 and 2 is that density. So we took the plan, we brought it into CityEngine. This is the aerial. We sort of put the plan on top. We started to then draw out our street network. You can see we deviated from the plan once we sort of got into a true testing program like CityEngine. We saw that the street grid just wasn't going to work with the terrain, so we had to modify it. We then used SketchUp to build out the areas that weren't part of the street. So we isolated where the streets weren't, took those blocks and brought them into SketchUp, placed the buildings, the parking lots, and then brought it back into CityEngine and applied those rules. So here we have scenario A. We got about 950,000 square feet, 281 dwelling units. You can see the parking. We wanted to make sure it parked. So based on the local parking requirements, this development would need about 1,523 parking spaces, and we're parking 1,543. Option B, we're adding parking garages, higher, taller buildings, more dwelling units. So here we're at 1.7 million square feet, 505 dwelling units. You can see that parking increased. And so we published this out again as a 3D scene inside of ArcGIS Online. We allowed our client to put one on top of another and sort of explore it. So this is what they're able to do. And inside there, they can query a building. They can click on that building and see that there's 28 dwelling units in that building, and it's going to need 171 parking spaces. And then in the more dense option, we're at 84 dwelling units that needs 285 parking spaces. One of the things they were concerned about was that they'd be creating a cavern if they went to tall buildings. So the people that were opposed to the density, they were most concerned about creating a cavern. And here you can see that shot down the street. And honestly, I think when I saw this on ArcGIS Online, I was concerned with creating a cavern as well. But the next step was to bring it out of GIS and bring it into a game engine. So inside of SketchUp, we created these blocks for trees and light poles. We also went into Photoshop and created a series of street textures. We're trying to make this as visually rich as possible. So adding things like oil stains, tire wear, cracks, manholes, patches, light patch, dark patch. Built this giant texture library for lanes, and you can see those file names, lane-014, lane-234. Well, that was a naming convention we came up with. The first numbers was happening on the left side of the road, the middle, whether it's clean, got tire wear, and then the right side. And then inside of CityEngine, just this line of code here, this starting at 534, randomizes the streets. And so we get a street that, we think looks a little more natural, how kind of streets look. They take a lot of wear and tear. The other issue we had to deal with was grade. Doing work in 3D on a flat surface is very easy. When you start to introduce grade, it starts to become a little challenging. And so this is the Morrisville downtown as a flat plane. But when we looked at the terrain, we see that it sort of has some rolling hills. So that door, for example, would never be there or would need a step. And so we built in some handles inside of CityEngine, gave our designers the ability to sort of explore door location. Does it work if I move it to the right? Still too high? I can change that facade altogether and just make it a window. So that was sort of how we went through the design process. It resulted in, brought it in then to the Unreal Game Engine and gave the town the ability to walk through this future area to see what the downtown would look like. So when they push play, we spawn our character Malcolm. He's able to run through the town center and see. This is option A. And there's all the data from the development, and then option B. And then they're able to sort of click that Superman button and fly around the area. So we went to a town council meeting, presented for about 30 minutes. They had us travel to all different parts of the town center, and ultimately they decided that the dense option wasn't too dense. They weren't creating a cavern, and a unanimous recommendation by the town council to move forward with the more dense option. So that workflow, we were in and out from ArcGIS Pro to hand sketching, CityEngine, Photoshop, back into CityEngine, into SketchUp, back into CityEngine, publish out that web scene. So you can see the process can be, there isn't just one tool that allows us to do what we do. We're in and out of a few different pieces of software. Final example I'll go through before I hand it off to Sujan, how we used a digital twin to help the village of Glen Ellen evaluate new development. Similar thing, we were working with Glen Ellen on their comprehensive plan. Part of that planning process had a lot of outreach and engagement. And what we learned was how cherished the downtown was. And then in our vision statement that we wrote, we say something here that sort of looks like they're competing interests. We say that Glen Ellen's historic downtown has an active pedestrian-oriented area containing a mix of shopping, entertainment, dining, and residential uses. While downtown continues to be small and compact, the residential densities are increasing. There's a greater mix of stores, variety of businesses. And so that's what the community wanted for their downtown. And to give you an idea of what we're talking about, 3 to 4 story buildings, a lot of historic architecture, sidewalk cafes, but all new development faced similar challenges. They proposed something, they would be met with resistance over height, density, style, architecture, and color. So a typical development scenario, if you work in the public sector, you've seen these watercolor drawings that developers show, elevations and floor plans. But they wanted more control over development. They wanted to make sure that it would fit with the character. So they asked us to create a digital twin of their downtown. We started ArcGIS Pro. All we had was 2D information. So we took LiDAR through 3Depth. We brought that LiDAR into ArcGIS. We then looked at the roof forms. So we're pressing that LiDAR information down onto the footprints. We're segmenting out the building forms. We're getting the heights. We're also using, this is a local government solution, by the way. So if you're an Esri customer, this is available to you. We look to publish trees. So looking through that LiDAR information to see where trees are. So we got the vegetation, we got the building heights. We also had to look at grade. You can see the 1-foot contours through here. There's some grade within the downtown. Built an elevation map and a digital elevation model. All of that was brought back into CityEngine, where we started to drop our shapes. So we had our building footprints, and we dropped those to the high point of each site. We have the different streets, everything sort of following that grade. And then our rules in CityEngine, we extrude up, and then we also have to extrude down. We don't want there to be holes in the surface, and so we're building those foundation walls, those retaining walls. So that was sort of how it was put together. And then for the ground itself, we created this tessellation grid that would allow the grass areas, the yards, to sort of hug the terrain. So that's what that checkerboard grid is. So this was the final 3D model inside of CityEngine before we left to go to the Unreal Engine. We also did work in SketchUp. This was the proposed development, and then we modeled the library, which was right across the street. So this was the first project that they did. Concern there was compatibility with the library. So what we have done for them, they have this application where they launch it. And again, they spawn the character, and they're able to, everything in white is the existing building. They're able to sort of see the development that's being proposed, and whether or not they want it, they want to see. They can travel around to every active development within the downtown. So here's the parking lot with 1-story buildings, and this was what was proposed. And so a building like this that's taking advantage of that grade coming down the street. And they're able to, again, fly around just like the Morrisville, and sort of, they can click that camera buttons, create snapshots, save them in their staff report. So this is inside of the game. This is what was built inside of the Unreal Engine, and then what was built. So did a pretty good job of helping them navigate this decision. Development process is a typical development process across any plans are prepared, you get staff review, you get feedback. Plan commission is where you start to get public input. Plan commission's giving feedback. Developer goes back to the drawing table, comes back with a refined plan. Once plan commission approves it, it goes to the elected body, city council, village board, where again, there's more public input. Developer gets that feedback. What it looks like now in Glen Ellen, the 3D models are submitted by a developer. We use our 3D tools to update our digital twin. We republish out that immersive experience, and then they use that Unreal Engine playable game throughout the entire development process. So I'm going to transition this over to Sujan. Before that, we got one poll question here for you. Dan, if you could your next question. So do you have the capacity within your organization to learn these workflows? Should mention too, at the top of your screen, you should see a Q&A. If you want to ask any questions, we're going to leave time at the end to answer questions. You can submit questions there. So about a third of you are fully capable. That's great. A quarter have staff but could use assistance, and then about half of the people are saying we need help in this area. So great. Sujan, take it away.
Thanks, Evan. So next we're going to walk you through our work developing a digital twin for the municipality of Dubai as a proof of concept to showcase how they can leverage their GIS data and transform it into an immersive 3D world. So what we call a digital twin, they call it a metaverse. Here's how we started though. So um, we received layers like building footprints, roads, water bodies, open space. It's just the usual kind of like GIS data set that any city would have. And then this is what it looks like in ArcGIS Pro. But what we wanted to build was a visually rich, immersive digital twin. So we kind of took it into CityEngine and created a tool that would assist our team to design the buildings that have the rich facades. Here, I'm working in CityEngine using a custom CGA bool created for this project. I was able to design with these handles and color swatches, looking at images, trying to mimic the facade patterns of the buildings. The project, I would say the project was kind of like had a really compressed timeline. We met the city staff at the GITEX conference in Dubai on October 16th, and they wanted this done by Thanksgiving. We came back, scheduled a call, agreed upon the scope of work, and then we just had a couple of weeks to get this done. We framed out a work plan, and that resulted in like us being able to spend only 15 minutes per building, and we just had to work really fast, and then the tools that we built should allow us to sculpt the facades. So this is the workflow. I looked at the pictures of the buildings on Google that people shared, or the street imagery, and was able to move through downtown, trying to mimic or like trying to replicate the design features and the aesthetics of the building. So here you have the address downtown with the imagery on the side, and then this is what the whole downtown looks like. And the result is a visually stunning, rich model that is a blend of buildings pulled in from online data sources, as well as the buildings that we modeled. The buildings you see in white are streamed from the cloud, and then anything that you see that has a that was like fully textured are the ones that we modeled in CityEngine. So we quickly went through and pulled together these stunning visuals and put it all or packaged it into an application. So this is just going to be a demo of the Metaverse app that we built for them. We brainstormed with their team on the applications or use cases that are important for them. So we landed on 4 different use cases. The first one being just being able to, explore downtown Dubai. Here you can see the environment as it's built in the game engine. We're able to pan around, zoom in, zoom out, and then similar to Glen Ellen and the Mooresville examples, we're able to just explore the environment. You'd be able to walk around and just like click on a building and query the data. When I click on a building, what we do is we put out a REST query, and the application figures out what building it is and pulls in the relevant information. You can also fly around like you saw in the past 2 digital twin examples that Devin shared. And then it's fully configurable. You can change the environment of the day, and then similar to what you were doing earlier, be able to get the data. The routing example or the option is kind of interesting. Dubai has their own addressing system called the Makani number. So if you look at the top left, the number that you see next to the building name is actually the coordinate to the entrances of the building. It's not a point. It doesn't point to just a building on this along the street, but to an actual entrance on the building. What this allows is like for, let's say, emergency services to go straight to a particular door or entrance and not be wasting time. So what we do is once you put in the routing option, you are able to, we send it to ArcGIS Online, solve the route, and stream it back to the game, and have the character move along the path. As you just saw, you are able to just pan around and then look around as well. In the planning option, you've already seen how effective immersive environments were in Glen Helen and Morrisville. So we kind of built a similar kind of interface, a scenario planning interface for the municipality to test their different development options. As you switch between the scenarios, the pop-up on the left here kind of gives you the pertinent information about things like retail, office, or hotel square footage. What's the FAR of the building, and then what are the number of jobs that were generated if we were doing this. So these kind of things in the data is being driven by the CityEngine work that we put into doing this kind of scenario planning models. And the final example is the real estate use case. This option, kind of shows you if any space in a building or on a floor is available or not. Any space that you see that's in red indicates that it's available, with the blue being not vacant. Unlike the other cases, though, everything that you see here, the data is stored in ArcGIS Online and is being maintained by the municipality. So as soon as the data is updated, the model kind of reflects the change. So yeah, this was kind of like what we did in a couple of weeks. It was a great exercise to show how the city could leverage their GIS data. So that was it for Dubai. And yeah, moving on to our third poll question. If you could put it up on the screen, Dan. Are you currently involved in a project or have an upcoming project that could benefit from a digital twin? Almost a half, or almost 40%, say that we have some projects where digital twins might be beneficial. A quarter say that we could potentially fit a digital twin in our existing project work. And then almost 15% are saying that we would like to find projects where we could do this sort of work. So with that, over to you, Rob.
Thanks, Sujan. Hey, everybody. All of you on this call, I'm sure, know that cities and organizations need tools to manage infrastructure and assets. And a real common way of doing that is through a ticketing system. So what we're going to do now is actually look at a live demo of using a ticketing system on a digital twin platform called twinit.io. Now, Twinit uses ArcGIS components pretty heavily, like this 3D web scene you're seeing here. And what we've done is we've actually divided up the city into these maintenance districts. By the way, you can kind of look out over Lake Michigan here. So if I click on the theater district, what will happen is we'll drill in on this district or region, and we get some good regional information, like the number of buildings in this area. There's 42. They're kind of, most of them are sort of obscured with this cartoony outline. The number of tickets is about 14 across 5 buildings, but then also you'll see this yellow building down here. And what this is actually a BIM model being streamed in as what's called a building scene layer from Housel Levine's ArcGIS Enterprise. And if we click on this thing, we'll jump inside the building or jump in front of the building. Twinit's actually loading a new or a different viewer right now. You'll see down here in the right, there's an overview and inset map that gives us a sense of where this building is in relation to the district, other districts, and the number of tickets around it. So we can do kind of standard stuff with this building, pan, zoom, orbit, hover, look in some windows through the glass, see some nice staircases back there. If we go back up to the roof and click this component, we can get some useful information about it. Like, for example, that it's a chiller. It's in space 212. It's created by this manufacturer called Klima Veneta or Veneta. And then some extra information like that it's got 4 compressor circuits and uses 732 kilowatts. But this is really about tickets, so let's take a look at the tickets. There are 4 associated with this building. This one here, a noise complaint from the boiler, we can jump inside the room and take a look at that. This view is enormously valuable in terms of having this sort of digital twin representation of the building, because now we know where in the room this component is. We know where it is in relation to other components. We know where it is in terms of where it is in the building. So if a technician has to go out here and take a look at this noise complaint, they just walk in through the door and go left, and there it is. So this digital twin example really enables a regional to room scale view of city asset management. Now, what we're going to do next is take that same concept, that regional to room scale view concept, and apply it to, let's just call it a preview application for tourism. So again, we're back in Chicago, very similar 3D scene. We've got our districts again. There's Lake Michigan, Millennium Park, where the bean is, and we can drill in on a district. This time we see a similar number of buildings, maybe some different symbology. And this building that I'm highlighting right here with the cocktail glass above it, that is actually the world headquarters of Housel Levine. It's called the Randolph Building. And when I clicked on it, it dropped me into that immersive experience, a video game that we've seen a few times across the last few minutes. And now what we can do is we can run Malcolm through the scene or walk him. And let's do this. Let's take a look up at this building. This is the Cadillac Palace. It's a beautiful theater. And since we are using a tourism use case, let's go inside the building. Here's the inside. You can see it's got some beautiful ceilings. We're in the lobby, by the way. At the time we took these pictures, the Frozen show was playing. Maybe some of you actually saw that. If you're familiar with Matterport, you'll recognize this kind of digital tour experience. This is actually using a component called Panellum. But let's jump back out on the street and run over to the Randolph Building. So again, the Randolph Building is this gorgeous Art Deco building. It's where Housel Levine is headquartered. We can go inside it as well. Here's the lobby. Obviously looks a little different than what we just saw, but we have that similar digital tour. So let's just say, I don't know, I'm renting an Airbnb in this building. This application, this experience gives me the ability to actually preview and see what's there. Maybe I like to swim, or perhaps, what else can I do up here? Well, there's a game room back here. Here comes a pool table. Nice picture of Bobby Hull missing a couple of teeth up there on the screen, and Miss Pac-Man. So again, we've created this kind of virtual world to help us get a sense of where we're going to go, what we're going to see, what we can do. There goes the train. And of course, this being a video game, I can fly. And the nice thing about this is that this gives me just a beautiful view of Chicago's gorgeous skyline. Notice that right in front of you, that reflective building, that's actually reflecting the roof and the facades of buildings around it. So this is the kind of thing you can do with a digital twin, is enable all these different experiences, tourism, ticket management, and more. So I'm going to end here. We'll do our final poll question. So Dan, go ahead and flash the poll, and then we'll wrap it up. We have the question.
Yeah. Which aspect of the digital twins interests you the most?
All right, there we go.
Yeah, kind of a broad. That's all of it, right? Real-time integration, all the above. 3D visualization is the most, and then simulation, scenario testing. Great, thanks, Rob. I am going to wrap it up with one final thing. I'll just take a couple of minutes. We've been doing a lot of work for undisclosed, projects under NDA. We can't really disclose what they are, but what we have done is a lot of work with master plans and digital twins for master plans. And here's an example we'll show you. If you're a planner, you probably know about a guy named Ebenezer Howard. In 1898, he had a book called Tomorrow, A Peaceful Path for Real Reform, where he introduced a concept called the Garden City. These are these cities, 32,000 people. And his vision was there wouldn't be one metropolis. There would be these garden cities spread all over. So it sparked a revolution in planning. Now I think it would be, when we look at it, it's widely criticized for promoting sprawl. 32,000 people in the size area isn't transit supportive density. And so we took Howard's vision and we applied it to a master plan. And so you can see this. Here's a link for you, hla.fyi/Garden City. Dan, maybe you could put that in the chat. It'll take you to this story map. This is what we did, similar workflows using CityEngine and the Unreal Engine and NVIDIA Omniverse. We built this this city. And so instead of 32,000 people, I think we have about 1 million people in here, about 600,000 jobs. It's a self-sustaining city. And I'll just walk through some of the images from it. We address things like mobility. We have transit supportive densities. So what does it look like inside of CityEngine? We built that graph network, strictly following Howard's Garden City concept. From there, that helped us create streets and intersections, where we then applied rules for shapes for the sidewalks, the streets, the intersection, and roundabouts. That was then subdivided into parcels. And we set parameters for lot width, lot size, street access, street alignment. So CityEngine gave us those parcels. We then divided it into rings and wedges. We looked at the rings 1 through 8, starting at the middle, at the center out, ring 1, 2, 3, 4, 5, 6, 7, 8, and we also did wedges. And those rings and wedges helped us define attributes for land use, setbacks, density, and height. We have a transit network, so we did a continuous looping public transit. And for people movers, we have a red line and a blue line. And then CityEngine helped us then create these land uses and reports driven by parameters and attributes, the 3D model. And then finally, we applied texturing. And from there, we exported into the Unreal Engine. And so you go to the story map, you can kind of see what how it looked like between the textures and non-textures. We've talked a lot about CityEngine and their rule-based modeling. This will give you a quick overview of how it works. So you can see at the bottom, you have this shape. That's the initial shape. We draw the center lines, we get those shapes. From there, we get our rule will look to find a footprint. And so we apply setbacks. We create that plaza around the building. We find a footprint for a skyscraper. We extrude that mass. So buildings in the center, random heights between 80 to 300 stories, or 240 meters to 900 meters. We then split that mass recursively. So 95% of the splits get progressively smaller. 5%, you can see up at the top, gets a little larger. So creating these randomizations so it doesn't look basically adding diversity. And then we also look to put holes in the buildings. We split each mass. There's a 60% chance it's going to be replaced by a cylinder or an octagon, and then it might have a hole punched through it. So all of that really helped diversify that skyline. And then we randomized the textures. We built all these textures in Adobe Illustrator. So these textures were done by hand in Illustrator. We brought them into Adobe Substance, where we added things like normal maps and reflectivity. And then the whole thing came together with inside of the Unreal Engine as a playable game, as well as a GIS. And so inside of this game engine, I can query any single building. It'll tell me how many dwelling units are there. And so I can move the playable character around. As soon as I click on a building inside the UI, we're going to do a REST query into GIS and find out how much power it takes, how much power is it harvesting from rooftop solar. So this is I guess an example of the kind of work that we've been building throughout the world. So with that is the last slide. Closing remarks. Just that, we love this kind of work. We think it is definitely helping us as a firm make smarter decisions and better plans. It's certainly it's been a lot of fun getting to learn all of this software and helping cities out all over the world. And so Keith had a contact slide. There's Keith's email. The rest of our emails are up there. And again, just a reminder, we got some time left over for Q&A. I've been answering some of the questions as they've come in, but feel free to let us know if you have any questions. Will recording this be available? Yes. Dan, do you want to let Harvey know where the recordings will live once they're done?
Yeah, Harvey, we will be posting this to our website, so they'll be available on YouTube. We will send an email to everybody who attended the webinar with the link. Thanks.
Someone asked earlier, and I responded, was our games packaged as installation files and passed to each stakeholder? The game was packaged. We deliver it to the community. They have shared it so residents can download it. You do need a 3D graphics card, I think, to get the optimal experience. It will run on most PCs. Something Rob didn't mention when he was going through the Twinit example was that he was in a web browser running through Chicago. And so that was getting cloud rendered. There's a cloud GPU that's called pixel streaming that streams it into a browser. So if you don't have a 3D card or if you're on a mobile device, there's a technology out there called pixel streaming, which handles a good part of the legwork in the cloud and then streams down into a browser. And so it isn't an installable file. You just go to a website. There was a question what I meant by cavern. That's just the urban design principle of sensitive enclosure. When the buildings are too tall, there's not enough sunlight coming in. And so it's sort of common to hear people say we're creating a cavern. I think we answered the next question. Can models incorporate schematics? I think you saw a wide range of different types of models we've incorporated, from BIM models in that ticketing example, GIS, and some of the other 3D work. How many people worked on this CityEngine metaverse? The Dubai example, I'm assuming, is what I think we had about 4 people work on it. And we met the municipality of Dubai at a conference in Dubai called GITEX in mid-October. I think they hired us and turned us loose at the first week in November, and it was due in Thanksgiving. So we only had about 3 weeks to do it. So John did all the buildings. I want to say he had a time budget, or he budgeted about 15 minutes a building. So we definitely had to work quick. And so 4 of us worked for about 3 weeks to get that done. All right. Well, we're right at close. There's no more questions. We'll go ahead and wrap it up. Thank you so much. Hope you enjoyed the webinar. And we do have one more. Do you model seasons other than winter? Yeah. I guess model seasons other than summer. Yeah, no question. Chicago looks a lot different in the winter. We can. There are, if you've ever used Twinmotion, you can cycle through the seasons very quickly. We can make it rain. There's a lot of different weather effects. We can introduce real-time weather if we wanted to. Having the sky and the clouds and the sun mimic what's out there. So yeah, depending on what the ask is, if you wanted to see it in a different season, we can definitely do that. All the 3D models we use have for vegetation have 4 different seasons associated with them. So, do you have specific software developers that are assisting with REST API development or utilizing GIS developers? We do everything you've seen was done in-house, with the exception of the Twin example. We worked with the Invocar team to do some of that. But we do all of the REST API integration internally. We have software developers on team. Rob is a practice lead with specialization in software development and solutions. So thanks for the question, Max. So yeah, that's it. Thank you very much. Hopefully you enjoyed us. Feel free to connect with us and have a great rest of your day.